Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so question 3 in the 2020 paper was the complex number question. So Z1 is equal to 3 minus 4i, Z2 is equal to minus 2 plus i, Z3 is equal to 2i, Z2, where I squared is equal to minus 1. Write Z3 in the form a plus bi, where a and b is an element of Z. Okay, I am going to my log tables to show you where this fits in the whole grand scheme of things. Okay, and I'm looking for all the different number systems. Okay, so remember our number systems, so our natural numbers, counting numbers, integers, our z's, they're all the whole numbers, negative, positive, and 0. Our rational numbers are our fractions, okay? And remember, all of these can be written as a fraction, so they are also all rational numbers. Remember our irrational numbers, they cannot be written as a fraction, so the square root of 2 is an irrational number, pi is an irrational number, and all of these, including the irrational, are all real numbers, okay? And then you have this branch of maths that sits outside of real numbers called complex numbers. A plus bi is your complex number. So it's this letter I that you will know to be a complex number. Okay, so if it's okay with you, I'm going to spend just a little time, because my first question on complex numbers, a little bit of time talking about complex numbers. Okay, so I'm drawing a graph. I am going to make up a quadratic. So remember our quadratic, ax squared plus bx plus c is equal to 0. And you know if we plot a quadratic, we get a smiley face or a sad face, okay? And these values here, where it cuts through the x-axis, are what we call the roots of the equation. And when we solve the quadratic, we get them. So that's a normal quadratic. Now that's related to complex numbers, and I want to show you how. So I need to make up a complex number, 2x squared plus 3x minus 12 is equal to 0. Now I hope this works, okay? So I'm going to solve it using the minus b formula. Okay, so my a is 2, my b is 3, and my c is 12, okay? So minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now if I put that into my calculator, so I'm just grabbing my calculator there. So I'm putting into my calculator not the square root sign, but 3 squared minus 4 bracket 2 bracket 12. Okay, and I got minus 87 all over 4. Okay, now what happens if I put the square root of minus 87 into the calculator? And I want you all to try that. Square root of minus 87. And what you'll find is you get a maths error. Okay, and you get a maths error because in maths, as it stands like this, you can't get the square root of a negative number. Okay, so although that looks like a quadratic, and we'd expect it to plot like a quadratic, it's not letting us solve it. Okay, which means there's no values for x. Okay, so what does that mean? Well, what it actually means is if I was to plot it, okay, now, and I haven't done it properly, so this is just a rough graph, but if I was to plot it, sorry, it would plot, let me just see if I can draw it properly, it would plot something like that. So what's different between this one here and this one here? Well, can you see that one never cuts through the x-axis? Okay, so this will go on forever and this will go on forever, but it'll never come down here and cut through the x-axis. And you see these two x's I have drawn here, they are the solutions of that quadratic. They are what x is equal to. So because that graph never cuts through the x-axis, in other words, it has no real roots, this doesn't solve as it is. Okay, so that there was born the subject that is called complex numbers. Okay, so how do we get around it? Well, instead of this square root of minus 87, we break it up into the square root of 87 multiply by minus 1. Okay, now if I multiply them together, I'm going to get minus 87. Okay, so why did I break them up? Well, root 87, I can put that into the calculator. That's a number. And then do you see the square root of minus 1? There's a rule in Certs that tells me I can write any number like, well, no, I won't write it like that in case it confuses you. Okay, so like this. So this becomes the square root of 87i. Okay, where I is equal to the square root of minus 1. So in other words, I separated out the minus there, or I squared is equal to, so if I square that side, I square that side. And you'll find the square and the square root sign cancel, and I squared is equal to minus 1. Okay, so then can I solve this now? Well, yes, x becomes minus 3 plus or minus. I'm going to put the square root of 87 into my calculator and decimalize it. So I'm going to say 9.3. See, the letter I comes after it, all over 2. Okay. And then how do we solve it? Okay. So I'm going to come up here now and show you how will I finish it. I will split it just like I would any other quadratic, so that I get minus 3 plus 9.3i over 2, and I get x equals minus 3 minus 9.3i over 2. Okay, and you can write this, if you wish, as minus 3 over 2 plus 9.32 over I, and this one is minus 3 over 2 minus 9.3 over 2i. Okay, this is what we call the real part of the number, and this one with the I on it is called the imaginary part of the number. It's just what they're called in complex numbers. Okay, so the real component and the bit before the I, the imaginary part. Okay, I should have taken the minus sign. Okay, and that becomes the chapter of complex numbers. That's where it came out of. Okay, now one other thing, how do you know that this is going to happen? Instead of the letter X, they tend to use the letter Z for complex numbers rather than X. Okay, so let's go back to our complex numbers. The first one is 3 minus 4i. So this is the real part, this is the imaginary. Z2 minus 2 plus 1i, and Z3 is 2i by z squared. And they tell you that I squared is minus 1, or the letter I is the square root of minus 1. You can be told either of those two pieces of information. And they want you to work out Z3 and write it in the form a plus bi. So this is often called Cartesian form of a complex number or rectangular form. And it's the normal form for a complex number. Okay, so how do we do it? Well, Z3 is 2i times Z2. Okay, so you leave the 2i there and let's sub in Z2. Okay, so I just replaced Z2 with Z2, the complex number. And let's multiply it like you would any other algebra one. Okay, so 2i by minus 2, well, we multiply the letters by each other. 2 2s are minus 4i, and then plus 2i squared. Okay, so 2 and then I have I by I being I squared. Okay, you never leave I squared in a complex number because it's -1. Okay, so I squared actually makes this part be real. So instead of I squared, you always sub in this -1 up the top. Okay, so it's -4i minus 2 ones are 2. And then you always write it with the real part first and then the imaginary. So it's equal to -2 minus 4i. So that is Z3. Okay. Now, next part of it, plot Z1, Z2, and Z3 on the given Argand diagram. Okay, so the Argand diagram is what we call where we plot them. So it's called a Cartesian plane when you're doing the line or the circle or anything like that. It just has a special name in complex numbers called the Argand diagram. Okay, so this is what we call the real axis. Okay, it's the traditional x-axis, and the traditional y-axis is the imaginary axis. Okay, so let's grab our complex numbers. So there's x1 and x2. Let's copy them over to here. Okay, and let's see, what did we get for Z3? Let's take a little copy out of him. Okay, and let's plot. Okay, so Z1, can you see that, is 3 minus 4i. So I go across to 3 on my real axis, that's the real component, and I go down to -4. So you just take the numbers when you're plotting. The I just tells you that that's the imaginary part of it, okay? So -3, and then I go down to -4, okay? So -3, -4, so that's my Z1, okay? Z1. Okay, Z2, -2, so you go on the real first, plus 1i, okay? So just like with the x, we tend not to put in the 1 in front of the I. And Z3 then, -2 minus 4i. So that's Z3. So make sure you always label your complex numbers as such, and that's how you plot on the Argand diagram. Okay, so quite a few marks for being able to do this. It could be either 5 or 10, and this could be either 5 or 10. Okay, so good marks for complex numbers. Okay, and then it says find the 2 lines and Z1. Okay, now you would have met those 2 lines before. If I can point them out to you, you would have met them here. Okay, so what did they mean there? They meant the length of PQ. Okay, and they kind of mean the same thing too. It's called the modulus of PQ. Or Z1, sorry, in this case. But what it means is actually the distance from the origin. Okay, so it's asking you how far is Z1 out from the origin. Okay, so how do we do it? Well, there's a formula, but I want to explain where the formula comes from. Okay, so I can form a triangle from Z1 with the x-axis, okay? Okay, so then you can see that when I do that, I have a right angle here at the x-axis, okay? So I have a right angle here, which means this side here is my hypotenuse. Okay, now what length is this side here on the x-axis? Well, remember Z1 came across 3, so it's a length of 3. How length is this side here? Well, remember we came down 4. So it's a length of 4, okay? We don't put in the minus is direction. It's just a length of 4. Okay, and now if I asked you in a triangle, how would you get the length of this side? Well, then I would hope that you would tell me Pythagoras' theorem. Okay, so to find the modulus of a complex number, its origins comes from Pythagoras' theorem. Okay, so it's the square root of a squared plus b squared. Okay, so Pythagoras' theorem told me that c squared was equal to a squared plus b squared, or c, the length of that hypotenuse, will be the square root of a squared plus b squared. Okay, so can you see the similarities? This is all we're doing. Okay, so do you have to draw the triangle all the time? No. I'm going to put down z squared, or z1 here. So it's 3 minus 4i. That's your a, that's your b. Okay, so therefore I can say the modulus of z1 is equal to 3 squared, the square root of 3 squared plus minus 4 squared. And look, no I, there's no I in it, okay? I just tells me which one is b. So put that into your calculator, make sure if it's a minus number, it's in a bracket, and you'll get the square root of 9 plus 4 fours are 16, which is the square root of 25. So the modulus of z1 is equal to 5. Okay, very important to be able to do this. It comes up quite a bit. Okay, if z1 by z4 is equal to 29 plus 3i, write z4 in the form a plus bi, where ab is an element of R. Okay, these can be quite confusing as they're written, but if you know any of the complex numbers, write them in where you know them. So z1 was equal to 3 minus 4i. Okay, so 3 minus 4i times z4 is equal to 29 plus 3i, and I have to find z4. Okay, so how I would do it is I would divide both sides by 3 minus 4i. In other words, divide by the number in front of the letter that you want, just like we would in any other algebra question. They will cancel, and you're left with just z4 being equal to 29 plus 3i over 3 minus 4i. Okay, so now we come to the most difficult part, in my opinion, of complex numbers, and it's how you divide a complex number. Okay, one of the rules of maths, just like you're not allowed to divide by 0, and try that in a calculator and you'll get a maths error. Another rule of maths is you're not allowed to divide by an imaginary number. So I have to play some trickery to force the bottom to be not an imaginary number. Okay, so how do I do that? Well, you multiply it by, it's called the conjugate of the bottom. So that means I changed the sign in the middle. Out from that, it's the exact same. Didn't change the sign of the real part, look at that. I just change the sign of the imaginary bit in the middle. Okay, why do I do that? I do that to force him to not be an imaginary number, because you'll see when I multiply that now in a minute that the imaginary parts are going to cancel. Now, what I do to one piece of this equation, I have to do to the other. So I have to also multiply the top by 3 plus 4i. Okay, so why can I do this? And why is it okay? How is this the same as this? Okay, well, I'll tell you why. This number here that you're effectively multiplying by is 1. Okay, isn't any number over itself 1? Okay, as long as the top and the bottom are the same, you are multiplying by 1. Okay, and you know that when you multiply anything by 1, it's itself. Okay, so although this looks like we're changing the equation, we're not, because we're effectively multiplying by 1. But what it is doing for us is obeying the rules of maths, where we will cancel out the imaginary number and therefore not be dividing by imaginary number. Okay, so just like you would any other bracket, I'm going to do 29 by everything in the second bracket. And then I'm going to go back for the plus 3i by everything in the second bracket. And then on the bottom, I'm going to do 3 by everything in the second bracket. And then minus 4i by everything in the second bracket. Okay, and then I go mad multiplying. So 29 by 3, I wish I could do that in my head, 29 by 3 is 87. 29 by 4 plus 116i plus, now I'm doing 3i by 3, so that's easy enough. 3 3s are 9, and I just put the I after it. And this one, 3i by 4i, well, I do 3 4s first, that's 12. And then I do I by I is I squared. Okay, all over. We do it again. So 3 by 3, 9. 3 by plus 4i is plus 12i. Minus 4 by 3 is minus 12i. And then I have minus by minus, or sorry, minus by plus is a minus. 4 4s is 16. I by I is I squared. So the sign first, plus by minus is a minus. 4 4s, 16. I by I squared. And you'll always generally have an I squared in it when you're multiplying something like this together. You'll have a number and you'll have 2 I terms in the middle. Okay, so let's tidy it up. You cannot add I squareds to I. You can't add I's to numbers, okay? So just like any other algebra. So he becomes 87. I can add though 116 plus 9 to give me 125i. Okay, and remember what I do for I squared. I always sub in minus 1. You never leave I squared in a sum. Down the bottom, remember I told you the reason we do this is the i's will cancel. Okay, so you're left with on the bottom 9 minus 16, and straight away you sub in that minus 1 again. Okay, let's keep going. So 87 plus 125i minus 12. Okay, so what you'll see is the I squared will always change this sign. So you see the way it's plus 12, it'll become minus 12. This minus 16 will become plus 16. Okay, because I have 9, I have minus by minus is a plus 16. Okay, now I can merge the 87 minus 12. So it's 75 plus 125i over 25. Okay, so remember me saying I squared ends up being a real number. So the I squared that was down the bottom there ended up being a real number. So now see, I have no imaginary number down the bottom. So I'm obeying the rules of maths. So how did we do that? You multiply it by the conjugate of the bottom. In other words, you change the sign in front of the imaginary part. Why the imaginary part? Because it's the imaginary part we need to cancel. Okay, and then when you have the 2 bits over the 25, you can put each bit over the 25 like this, just like you would any other fraction. 75 over 25 is 3. 125 over 25 is I. Okay, so Z4 is indeed equal to 3 plus 5i, which is in the form a plus bi. Okay, so division is the longest and in my opinion the hardest part of complex numbers on the ordinary level course, and it just takes practice, and once you practice it, it's not too bad.
If you are interested in technology or engineering but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in Electronics and Self-Driving Technologies, and from there to the Masters.
Check out the link below for more information.